Hi everyone, welcome to this video. Today we're going to walk through what actually happens when you use a centralized infrastructure as code platform to provision infrastructure. We'll use Harness IACM as our example, but the concepts apply to any platform that orchestrates Terraform or OpenTofu. So there are a couple of concepts that I'm hoping you are familiar with. I expect that you know what Terraform is, that you've written some Terraform configuration files, you've run some Terraform plan and Terraform apply commands before. If not, you should probably go take care of that first, become familiar with Terraform before moving on with this video. Keep in mind that OpenTofu is just Terraform, but it's a slightly different version with different features. So if you are familiar with Terraform, then that's fine. I also expect you to understand Git workflows, things such as branches, pull requests, merging to main, and all of those things. Also hoping that you have some familiarity with CI/CD, for example, GitHub Actions. That's the one we're going to be using, but it's not strictly required. So I'll explain what's happening at each step. So let's move along. So why can't I just run Tofu apply from my laptop, right? Let's say you need to create a load balancer in AWS for your service, and you write the Terraform configs, you run Tofu plan or Terraform plan and Terraform apply. It's done. That works fine when you're a team of 3. But what happens when you're an organization with dozens of teams, hundreds of services, and thousands of infrastructure resources? The problems start to quickly stack up. So certain questions start to arise. Things like who ran what? There's no audit trail when someone applies from their laptop at 2 a.m., for example. Whose credentials were used? What about policy? There's nothing that prevents someone from creating an untagged resource or an unencrypted S3 bucket. What if there's state conflicts? 2 people run Terraform apply at the same time. So these are very common questions, very common problems that start to arise as time goes on and as the number of people in the organization starts to increase. So there is a solution to all of this. The solution is to never let engineers run Terraform apply and Terraform plan directly against production. Instead, you push your Terraform code to a Git repo and a platform that handles everything else, right? The platform runs plan and apply on your behalf in a controlled environment. It also provides authentication. It uses short-lived credentials and least privilege access. Another benefit is that you can implement certain policies. For example, you can check and make sure that any resource that's about to be created gets tagged appropriately. Right? You can also implement the security best practices. You can also be mindful of the cost. These are all things that you can have in place. The platform also provides an audit trail, right? Whereby every change is traceable to a PR or a review and approval. And lastly, you get state management, which ensures that your state is centralized instead of every developer having a state file on his or her machine. Another advantage of this is that the state is locked, so no Terraform apply commands running simultaneously result in conflicts. So let's go through a scenario to clarify what we're talking about here. So for the rest of this video, we're going to follow this concrete scenario. You're an engineer who needs to provision a load balancer and a database for a service. Let's call it the Weather API. And this service is going to live in your production AWS account. You're going to use Harness IACM as the platform and OpenTofu as the provisioner. GitHub Actions is going to be your CI system, and S3 is going to be your state storage. We're going to go through the steps from the config to the moment the load balancer and the database exist in your AWS account. In the beginning, there are a couple of prerequisites that need to be taken care of by the platform team at your organization. A Harness account with an org and project already created is one of the prerequisites, and this is typically set up by the platform team, as I've mentioned. You also need a delegate deployed on your Kubernetes clusters that's ready to execute the jobs in the pipeline. And don't worry about what this is. We're going to go in more details about this later. You also need a GitHub pipeline and AWS as well in order to integrate with Harness. So these are the platform level setup tasks that need to be performed. Once they're done, you as an engineer can focus on your infrastructure code. So the first step is to write the Terraform configs, right? So you're going to write these configs as normal, nothing special here. You define your load balancer, your database, your target group, listeners, all of those things that you need for your resources. The one important thing is that the backend configuration is pointing to an S3 bucket where the state is going to be stored. The key path encodes your organization structure. So it's going to mention the org, the project, and workspace, so the state files don't collide, right? And I want you to notice that your Terraform code has zero awareness of Harness. It's standard OpenTofu or Terraform with an S3 backend. You could run this locally if you had the credentials. Now you need to tell Harness, hey, I have infrastructure code at this path in this repo, and I want you to manage it. You do this by creating a workspace YAML file. This is a declaration. It doesn't create the infrastructure, but it tells Harness where to look when it's time to run OpenTofu or Terraform. So the important thing here is that this file alone does nothing, right? Like I just mentioned, Harness doesn't scan your repo and discover it. A GitHub action in your CI workflow, which we're going to see in a bit, reads this file and pushes it to Harness, to the Harness API. The YAML is just a config file. Your CI is the bridge. Also, the org and the project referenced in this file must already exist in Harness, typically created by the platform team or admin ahead of time. And this is one of the things we've covered in the previous slide. Okay, so your CI workflow has two GitHub actions that run sequentially. Each handles a different stage. You have the provisioner action, which reads your workspace YAML and manages the workspace definition in Harness. It ensures the workspace exists before anything else happens. And then there's your trigger action. This tells Harness to run a pipeline, for example, to run Terraform or Tofu or plan and apply for an existing workspace. So the ordering here matters. The workspace must be registered in Harness before a pipeline can target it. The provisioner always runs first. Both actions follow the same branch-based logic. So on a feature branch, when the PR is opened, the provisioner step validates the YAML, while the trigger step runs plan. When the PR is merged, the provisioner creates and updates the workspace, while the trigger step runs apply. The next thing we need to talk about is the authentication chain. So this is part of what makes centralized IaC secure. At no point does anyone store a long-lived API key or AWS access key in the pipeline config. The authentication is chained, meaning each step produces a short-lived credential for the next step. It starts with GitHub Actions workflow. The runner gets a short-lived token from GitHub's OpenID Connect. This token proves that this is indeed the correct workflow run, and this is the correct repo and the correct branch. And then the workflow uses that OpenID Connect token to assume an IAM role, and AWS trusts GitHub as an identity provider, right? So with this temporary AWS credentials, or with these temporary AWS credentials, the workflow fetches the Harness API key from AWS Secrets Manager. The GitHub Actions step can then use the API key to call Harness API, so it can, for example, create a workspace or trigger the pipeline. So every token in this chain is short-lived, it's scoped. If any step is compromised, the blast radius is limited. So what happens inside of Harness? So Harness receives the API call which says, hey, trigger the apply pipeline for the workspace, for example. But Harness itself doesn't run the OpenTofu or Terraform commands. It's a control plane, not a compute plane. It dispatches the work to a delegate. Delegates are long-running agents that you deploy in your own Kubernetes cluster. They continuously poll Harness and ask, hey, is there any work for me? When a task matches, the delegate picks it up. The delegate doesn't run Tofu directly either. It spawns an ephemeral worker pod, which is just a short-lived container that exists only for the duration of this pipeline run. When it's done, the pod is destroyed. So how exactly does the worker get the AWS access or the AWS permissions to do its job? The worker pod needs these credentials in order to deploy and provision your load balancer and database after all. But nobody bakes the credentials into it. Instead, it uses two IAM roles. So the first role, let's call it the source role, simply allows it to assume the second role, or the destination role, which will be used to actually build the infrastructure. So let's go through that again. The worker pod gets a source role automatically through what's called the EKS pod identity. This role has almost no permissions. It can only assume other roles. But how does this pod identity work? Well, the platform team configures the EKS control plane to automatically inject temporary AWS credentials into the pod. The pod doesn't fetch or request credentials. They're available the moment it starts, and it's injected by EKS itself. In other words, the source IAM role is there the moment the worker pod is initiated. Your Terraform provider AWS block tells OpenTofu to assume the target role in the AWS account where your infrastructure lives or is going to live. The source role is trusted to assume this target role. This means that the worker can only access the specific AWS account that the target role allows. A worker handling dev infrastructure, for example, cannot accidentally touch prod and vice versa. Now the worker has the credentials. It executes the standard pipeline stages, and the first stage is the init stage, where it downloads the providers and configures the S3 backend. For the plan stage, it generates the execution plan, basically what is going to be created, changed, or destroyed. And then there's the policy check. This is an OPA policy or OPA policies that validate the plan. Are all the resources tagged? Are any forbidden resource types present? Are the estimated costs within our budget? These are some of the questions that need to be answered, and that's what the OPA policies are there for. And then there is the approval gate for production, where the pipeline execution pauses. A human must approve in the Harness UI before proceeding. Afterwards, Tofu apply is executed. Your load balancer and database are now created in AWS. And then there's state verification, which confirms that the state was written to S3 successfully. So let's zoom out and see the complete picture. From the moment you push code to the moment the infrastructure exists, here's every link in the chain. Notice how many layers of safety are between your code and production AWS. Every layer has a single responsibility. No single component has full access to everything. So you push your code, the GitHub Actions workflow runs, it grabs the OIDC tokens, uses those tokens to get short-lived AWS access keys to the secret manager, and then it triggers the calls to the Harness API using the Harness API that it got from the secret manager. And then from there, the delegate spawns the ephemeral worker pod. The worker pod receives the source IAM role through the EKS pod identity, which then allows it to assume the target role in the destination AWS account. And then from there, all of the Tofu commands are going to be run. So Tofu init, plan, and then the policy check, the approval, and then the apply. And after that, the state is written to S3, which isn't represented in this diagram. And then the trigger action polls until it's done and reports the results back to GitHub Actions. And then your load balancer and database are created. So what do we get from all of this? It's important to revisit the improvements we've made since the beginning. We now have an audit trail. Every change is a merged PR with a review. You can trace any resource back to a commit, a review, and an approval. There are no static credentials in OICD. We use short-lived tokens at every hop. There are no AWS keys stored anywhere in the pipeline config, right? We also have policy enforcement, right? These policies check if our resources are tagged, and it checks all of those other things we've mentioned. There's also no state conflicts, only the platform runs apply. We're no longer running Terraform apply from our local machines. Instead, we now have one execution at a time per workspace. And lastly, each environment is isolated. A dev worker cannot touch prod accounts. So that concludes this video. Thanks for watching. If you found it helpful, please like and subscribe for more. Drop any questions in the comments, and I'll see you next time.